In this video, I'm going to talk about order of operations with fractions. Problems that look like this. Let's work this out on the blackboard. So you should remember your PEMDAS acronym for the order of operations. Right? Parentheses, exponents, multiplication, division, addition, and subtraction. We are going to evaluate this expression using operations in that order. So we'll start with parentheses. Are there parentheses over here? Yes. Is there anything to do inside the parentheses? No. If we had had something like maybe 1/2 plus 1/3 there inside the parentheses, then our first step would be to add those two fractions together. But we don't really have anything going on inside the parentheses. We just have the fraction 1/2. So we're going to move on to the next thing on our list, exponents. Are there any exponents in this expression? Yes. There's one right here, this 2. So our first step is going to be to replace the 1/2 squared with its value. So what is 1/2 squared? Let's work that out down here maybe. 1/2 squared. What this means is 1/2 times 1/2, right? Because that's what the exponent 2 means. We can write that this is equal to 1/2 times 1/2. And remember that when you multiply two fractions, what you do is you just go straight across the top and the bottom. You can only do this with multiplication, not with addition or subtraction. On the top, we're going to have what is 1 times 1? 1. On the bottom, what is 2 times 2? 4. Another way to get this answer would be to apply the exponent 2 to the numerator and the denominator separately. So we could write that this is equal to 1 squared divided by 2 squared. And I hope that you can see that that's going to give us the same answer, right? Because 1 squared is 1 times 1, which is 1. And 2 squared is 2 times 2, which is 4. So either way you do it, you should get that this part is 1/4. So I can write the rest of the expression, but I'm going to replace that 1/2 squared by 1/4. Okay, now we don't have any exponents. Do we have multiplication? Yes, we do. These two fractions are being multiplied. So now we should work on the multiplication. Let me clear this out of the way. Okay, so next we're going to do 7/9 times 1/4. Let's work that out down here. 7/9 times 1/4 is what? Again, we're multiplying two fractions, so we multiply the numerators, 7 and 1. 7 times 1 is 7. And for the denominators, we have 9 and 4. 9 times 4 is 36. So we can replace this part of the expression right here by 7/36. So our expression becomes 7/36 plus 1/4. Now we clearly only have one operation left, the addition, which is down here on our list. So now we're working on addition. To add two fractions, or to subtract two fractions, remember that you need to have a common denominator. So what would be a good choice for a common denominator of these two fractions? Or what is the least common denominator? A way to get a common denominator is to just multiply the two numbers. But there's a simpler solution here. See that 36 is a multiple of 4. In other words, we could multiply 4 by a number to get 36. Actually, that number is 9, right? It's right over here. So we can write these two fractions with a common denominator if we multiply the second denominator by 9. Now, we have to multiply this fraction by 1 because we can't change the value of this number 1/4, or it won't be equal to what we started with. So to multiply by 1 with a 9 in the denominator, we can do that by multiplying by 9 divided by 9, right? Because 9 over 9 is 1. So this really says 1/4 times 1. So this is going to be equal to what we started with. Okay? So in these two fractions, we're going to multiply the tops and the bottoms. And on the top, we are going to have 1 times 9, which is 9. And on the bottom, we're going to have 4 times 9, which is 36. And now we have a common denominator. And now we can add the numerators. 7 plus 9 is 16. Now we need to simplify this fraction, if possible. And we can simplify this, right? These are both even numbers, so we could start by dividing them both by 2. If we divide 16 by 2, we would get 8. If we divide 36 by 2, we would get 18. Again, they're still even numbers, so we can divide them by 2 again. 8 divided by 2 is 4. And 18 divided by 2 is 9. Now, can this fraction be simplified? Do 4 and 9 have any factors in common? No. The only factors of 4 and 9 other than themselves are 2 and 3, so they don't have any factors in common. And this is going to be our answer, 4 divided by 9. So let's go back over to Alex and put that in. Awesome, we got it right. Let's do another one. Okay, this one says 4/9 minus 2/3 to the power 3. So let's go over to the blackboard and work that out. Okay, again, we are going to remember PEMDAS. And we're going to start at the top. Is there parentheses in our expression? Yes, but there's nothing to do in there. Is there an exponent? Yes. Is 3. That's where we're going to start. So we're going to start by evaluating this part of the expression right here. What is 2/3 to the power 3? Let's do that over here on the side. 2/3 to the power 3. So whenever you have a fraction inside of parentheses with an exponent, and only a fraction, it can't be something like 1/2 plus 1/2 to the power 3. You can't do this the same way, but if you have just a single fraction, then you can apply that exponent to the top and the bottom number, right? And like I said, that wouldn't work if you had something like this. So if we apply the exponent 3 to the 2 up here on the top, we'll have 2 to the power 3. And if we apply the exponent 3 to the number in the bottom, that's 3 to the power 3. What is the top number? What's 2 to the power 3, or 2 cubed? That's 2 times 2 times 2, which is 8. For the bottom, we're going to do 3 times 3 times 3. Let's do that over here to the side. Right, this is 3 cubed. So what is 3 times 3? 3 times 3 is 9. And now we have this other 3 that we need to multiply by. What's 9 times 3? 9 times 3 is 27. So 3 cubed, or 3 times 3 times 3, is 27. So this part of the expression is equal to, not 8 over 28. It's equal to 8 over 27. Okay, so I'm going to replace that part of our original expression. 8 over 27. Now, to subtract these two fractions, we need a common denominator. What should our common denominator be? First, you should look to see if either one of these is a multiple of the other. Is 9 a multiple of 27? No, because 9 is smaller than 27. Is 27 a multiple of 9? Yes. 27 is 3 times 9. So we could turn this first fraction into a fraction with a 27 in the denominator if we multiplied that 9 by 3. And if we multiply that 9 by 3, we also have to multiply the 4 by 3. So we can write that this 4/9 minus 8 over 27 is equal to 3/3 times 4/9 minus 8 over 27. Right? So I'm multiplying the 4/9 by 3/3. I'm multiplying the 4/9 by 1. So I'm not changing the value of it. I'm just changing the way that it's written. So we'll multiply these two fractions to get our common denominator. On the top, we'll have 3 times 4, which is 12. And on the bottom, we'll have 3 times 9, which is 27. And then we still have this second part of our expression, the minus 8 over 27. Now we can do the subtraction. What is 12 minus 8? 4. And on the bottom, we have 27. Now, do we need to simplify this? Do 4 and 27 have any common factors? No. The only factors of 4 are 1, 2, and 4, and 27 is not a multiple of 1. Well, it's not a multiple of 2. So we cannot simplify this, and so 4 over 27 is going to be our answer. Let's go back to Alex and put that in. Oops. Okay. 4 over 27. All right. Good deal. We got it right. I hope that was helpful.